I know these have been some challenging weeks, but I have faith in you guys. We can do this. We're just adding polynomials. We got this. We got this.
Hey guys, so me and Miss May just want to let you know that we hope you are staying active. We know it's hard and you get stuck on your couch or just in your bedroom just hanging out, but even us, we're, before we're doing our lessons and stuff, we're getting a quick workout in, so just make sure that you're taking care of your body, and it will help your mind just to get outdoors, even if it's in the front yard in your bedroom. Do some push-ups, sit-ups, just do a little exercise. So that's going to be our keyword today.
Dun, dun, dun.
For our homework will be exercise. Okay, so pretty tough lesson today, but we're going to review the bell work and then go into the new part of 11.4, part 2, adding and subtracting rational expressions. So what Miss May taught you in the last video is that they already have a common denominator, but we are going to go ahead and factor it first. So 7q minus 3 over q plus 2, q minus 2. Again, remember, it only has two terms, so this is the difference of squares, right? I took the square root of both of them. Minus 6q minus 5 over q plus 2, q minus 2. Okay? Now that they have the same denominator, we're going to go ahead and distribute in our negative. So we're going to make that a plus, this a minus, and this a plus. So we are looking at a final denominator of q plus 2, q minus 2. We're looking at combining our like terms. So we have a 7q subtracting 6q, which will leave us with a 1q. And then we have a negative 3 plus 5, which makes plus 2. You should see now that you have something that can cancel. So our final answer will be 1 over q minus 2. All right? So the new procedures are similar, but some of them are a little bit more adding on to that type of problem. First example, we are going to add 5x over 6x plus 3 over 2x to the second power. We're going to first find the LCD. Okay, so looking at our constants, a 2 and a 6 can both turn into a 6. So that will be our constant. This is an x, and this is a x to the second power. So the LCD is they can both become x squared. All right, looking at the left one, we only need to multiply by another x, because 6x times x will make 6x squared. Okay, the other one, we have a 2x squared, but we want a 6x squared, so we're going to multiply it by a 3 and by a 3. On top, we are now looking at 5x times x, which makes 5x squared, over 6x squared, plus 3 times 3 gives us 9 over 6x squared. At this point, we have a common denominator. And we're adding 5x squared plus 9. Those are not like terms, so you're just going to attach them. Okay? This x squared and this x squared cannot cancel because this is a pair. So as Miss May does a lot of times, put it in parentheses, they are together. So that is going to be our final answer. Okay? The practice problem that you're going to go ahead and do first will be 3 over 7y to the 4th plus 2 over 3y squared. All right, guys, go ahead and pause the video and give that one a shot. All right, so we're back and we're looking at what was our LCD first. So our LCD, again, is going to be the common denominator that we're going to make. So looking at our constants, what number can 7 and 3 become? So 7 times 3 is 21. And then what can y to the fourth and y squared become for a common denominator? As Miss May just told me, she likes to tell you guys that it's going to be usually the biggest exponent. So y to the fourth and y squared can become y to the fourth, so we will keep y to the fourth. Okay? So what do we need? The 7 just needs to be multiplied by a 3 and a 3. This guy over here needs to be multiplied by a 7, but it has a y squared, so we need to multiply it also by another y squared. Remember, whatever we do to the bottom, we must do to the top, okay? So 3 times 3 will give us 9. Our 3 times 7y to the fourth give us our LCD. Our 2 times 7y squared will give us a 14y squared. And our 3y squared times 7y squared give us our LCD. Okay? Now that we have our common denominator, we're going to go ahead and add across. These are not like terms, but we will put it in standard form. Okay? Now, we're looking to cancel, but remember this is a pair. There's no number that can come out of 14 and 9, so that is going to go ahead and be our final answer. Miss May, anything to add?
Looks good to me.
All right, so flipping to the next example, that's a little bit more. We are looking at subtracting a 3 over d minus 1, subtracting a 2 over d plus 2. I would say the common mistake is we see that they both have d, okay? Since these are a pair, we must use both of those denominators. So our LCD will be a d minus 1 and the d plus 2. You're going to need to have both of them, okay? So on the left-hand side, we're going to go ahead and multiply this by our d plus 2, and on the top, a d plus 2. On the other one, we're going to do a d minus 1 and d minus 1, okay? Now, I'm going to go ahead, when I rewrite it, I'm going to go ahead and take that negative sign and I'm going to distribute it to the 2. So changing this into a plus and making this a negative 2. Okay, I'm going to go ahead and rewrite it here. So we have 3 times d plus 2 over d plus 2, d minus 1, plus a negative 2 times a d minus 1 over a d plus 2 over a d minus 1. All right, me and Miss May would like to tell you, a lot of the times on the top, you're going to go ahead and either distribute, FOIL, but on the bottom, we always want you to keep it factored, because sometimes you might be able to cancel at the end. So never, never, never on the bottom, refoil that back together, okay? Leave that broken apart. So on the top here, we're using the distributive property. So 3 times d makes 3d. 3 times 2 makes a plus 6. Over here, a negative 2 times d makes a negative 2d. A negative 2 times a negative 1 makes a positive 2. This will all be on top of our common denominator. Okay? Last step from here is to combine our like terms. We have 3d's subtracting 2d's to leave us with a 1d. We have a positive 6 adding to a positive 2, which makes a positive 8, all over our common denominator. Now, again, we told you not to FOIL on the bottom because sometimes something might cancel. But in this case, since they are all pairs and none of them are exactly the same, that will go ahead and be our final answer. So this requires you guys to really take your time. If you rush, you're going to make mistakes. So really take your time. Miss May, anything to add that you see?
Looks good to me.
Okay, so for the last example and practice, I'm going to go ahead and write them both down. So the example here is 2x plus 1 over x plus 4, subtracting an x minus 3 over an x plus 2. And the practice problem that I want you to go ahead and try first will be a c over 3c minus 1, subtracting 4 over c minus 2. Okay? This one here is pretty similar to the one we just did. So go ahead and give that a try right now and pause the video.
You can do it.
Okay, so on this next practice problem, again, we need to start with our LCD. These are two different binomials, so you're going to need both of them. So a 3c minus 1 and a c minus 2. That's what we're trying to make in our denominator. So the left one needs the c minus 2 and the c minus 2. And our right one needs the 3c minus 1 and the 3c minus 1. Okay, remember we're going to go ahead and get rid of that negative sign by distributing it. So we're going to change this into a plus and making this become our negative 4. Okay, we're going to attach these, rewrite them. C times c minus 2 over c minus 2, 3c minus 1, plus a negative 4, 3c minus 1 over c minus 2, 3c minus 1. As you can see right there, those are going to be common denominators, so we know we're going to be able to add and subtract at the very end here. Use the distributive property next. C times c makes c squared. C times a negative 2 is a minus 2c. Distribute here. Negative 4 times 3c is negative 12c. Negative 4 times negative 1 makes a plus 4. All over our common denominator. Okay. From here, it's just combining like terms and seeing if we can cancel at the end. C squared. Nothing else. Okay? All right. We are looking at our negative 2c and our negative 12c, which makes a negative 14c. And we have just that plus 4. All over c minus 2, 3c minus 1. Now, you don't want to box it quite yet. You do want to see, can I factor this guy out? So if on the side, I'm doing the big X, 1 times a plus 4, that makes a negative 14. That's not possible, right? There are no factors that multiply to make a positive 4 and give us a negative 14. So the top is unfactorable. That will be our final answer, okay? The next one, real quick, this one is going to be challenging. For some of you, you might be able to give it a shot, so go ahead and pause the video and see if you want to give it a shot. If not, you can then unpause and continue the video. All right. On this last one, our LCD is going to, again, be both of these factors. It will be the x plus a 4 and the x plus a 2. On the left-hand side, we are missing our x plus 2 and our x plus 2. On the right-hand side, we are missing our x plus a 4 and x plus a 4. Okay, I'm going to go ahead and write the entire denominator on this one. We know it's going to be the x plus 2 and the x plus 4. On the top, on the left, we're going to be multiplying those two together. So I'm going to go ahead and just attach them. We're going to be subtracting those together. Okay, so we're going to be foiling here. We're going to FOIL here, and then we will distribute the negative after the fact. So our first times our first, x times x, or sorry, x times 2x will make 2x squared. Our outside terms will be x times 1. Our inside terms, 2 times 2x. And our last times our last will be 2 times 1. Okay? I'm going to go ahead and just keep this in parentheses, just to keep it separate from the other one. We're going to have our subtraction sign. And I'll do purple for this one to see it a little easier. My first times my first is x times x, which makes x squared. My outsides are x times 4. My insides is negative 3 times x. And then my last times my last is negative 3 times 4, which makes our negative 12. Okay? Now I'm going to zoom in a tiny bit here. What we're going to do right now is we're going to go ahead and distribute that negative to all of these. We're going to put this as a plus, and then we are going to make this become a negative x squared, a negative 4x, a plus 3x, and a plus 12. Okay? Do not forget, this is all still over our common denominator. Okay? So I'm going to go ahead and clean it up a little bit. We have 2x squared. X and 4x makes a plus 5x plus our 2. Okay? Plus, we now have a negative x squared. A negative 4 and a plus 3 makes a negative 1x. And we have our plus 12 all over x plus 2, x plus 4. Now it's just combining our like terms, okay? Remember, that's going to always stay our common denominator. Starting with our 2x squared, we're looking for x squareds, and we see another negative x squared. 2x squared minus x squared makes x squared. Now we are looking at the x's, so 5x. I see a negative 1x, so 5 minus 1 makes a plus 4x. And then the last one is our constants, plus 2, plus 12, which makes a plus 14. Now I truly hope that this is unfactorable, right? Because it's a long one. So we're going to double check it. 1 times 14. That makes a plus 4. The only two numbers I know of are 7 and 2, or 14 and 1, and none of those make the plus 4. So thankfully,
Woo!
that is it. And I'm very exhausted. Miss May's arms are tired, so we hope you do well. Please Zoom us if you need help. Stay healthy.
Woo!
See you later.